Hello, everybody. So, we're going to talk a little bit about telescopes. So, all of these amazing pictures that we have, like the Hubble um, and the deep field view from the Hubble, uh, and just all of these amazing, amazing pictures that we have come from telescopes. Now, this might be what you think of. By the way, these images come from space.com. Uh, this might be something that you think of when you think of telescopes. These gigantic things on the ground that they open up and they're looking up through the earth itself and taking pictures. Now, that's great. Something that, by the way, don't mind me as I flip back and forth between tabs here. As we're talking about telescopes, we have learned so much about space in the last 100 years, and I would argue we have learned so much more since we got a human in space. Putting a person in orbit around the Earth totally changed what we know about space. We are learning so much. This stuff changes. Every year that I teach this, there's new stuff. And I'm not joking, brand new stuff. When I started teaching, we knew black holes were a thing. We'd never seen one. We have an image of one, and I'll show you it at some point in time. But we learned so much every single year that it's constantly changing. One of the greatest advancements that we had was when we took this telescope and we launched it and we put a telescope in orbit around the Earth, and it was called the Hubble Space Telescope. Now, space telescopes, and we've talked about wavelengths and energy like this before, how there's so many different types. Look at this. Okay, we have refracting telescopes, radio telescopes. This is not a type of telescope. We have robotic telescopes. We have optical telescopes. We have infrared. We have radio waves. We have X-ray. I'm forgetting something, but anyway, we have all these different types of telescopes, and what they do is they each measure different amounts of energy. Now, if I'm looking at this one right here, the only energy that my eyes can actually interpret is the energy that's in this tiny little space right here within the visible spectrum. And that's all that we had to go on for the longest time. The Hubble is an optical telescope. So if I zoom in on this picture right here, this is a very famous nebula. And the one right here on the left, this is one that would be taken with the Hubble, okay? The Hubble telescope would give us images like this. Amazing as they are, yes. However, we can get so much more information if we change the type of energy that we look for. Now, what's the advantage of putting a telescope in space as opposed to keeping it on the ground? Now, I think I accidentally closed out of the picture that I want. So bear with me for a second while I find the picture that I want. Earth, image, Apollo, this one, I think, I hope. Yes. Okay, the blue marble. It's a lot of times referred to as the blue marble. If I take this and I want to make this bigger so you can see what I'm talking about. Okay. Oh, this one's really good. Okay, so you see right here, there's like this fuzzy line. Okay. That fuzzy blue line is the atmosphere. I had the opportunity to listen to Scott Kelly, the astronaut who spent a year in space on the International Space Station, and he talked and he had this video, and you could see the sun coming, actually, the way that things were moving, it was sunrise. Okay, so the sun was coming up and it lit up. You could see like neon blue the atmosphere and how thin it was. It would be like if I took a Sharpie and I drew a circle around this picture right here. That's how thin it was. That's the atmosphere. That's what protects us from being blown into smithereens by all of the super harmful radiation from the sun. That little thin blue line. Holy cow, that's amazing. But for telescopes, the ones that sit on the ground, even the ones like the Keck one, and there's one on, Hawaii Mauna Kea, it's above the clouds. Like you can see how high it is above the clouds. They put them in the highest places possible to get higher into the atmosphere. What the atmosphere does to these telescopes is it turns them into, so yeah, you can sit higher, but you're still looking so far out, and it's like you're looking through glasses that aren't yours. Or if you took dirty glasses, those of you that wear glasses and they're really, really, really smudgy, okay? It's trying to look super far out and focus when the lens is all dirty or it's not for you. So when we had the ability to take a telescope and put it into space and get it past our atmosphere so it doesn't have to look through that, we started getting amazing pictures. Okay? So these ones right here would be the ones that I would take. Sorry, this wasn't even the Hubble. This was the one that was taken from a telescope on the ground. When I change it to different, to space telescopes, I get images like this. Okay. I get images, I can get images like this. Okay. This is one of the things that they're working on with the solar project. They are looking at the sun with different types of wavelength. Okay. There's different things that we can learn about how much energy it's shooting out, about solar storms, so much stuff that we can learn from just from looking at the sun or even distant stars with a different type of telescope. Some of the other things, so the newest telescope is this one right here. It is the James Webb Space Telescope, and this just went up maybe a year ago, maybe. Probably right around a year. And what they've done is this telescope can look even further into the past or closer into the center of the galaxy. So what they're doing with this, so here's this one, yes. So this right here, this is an image that was put together. Now, the James Webb Telescope, I believe uses, it does not use optical. I think it's either infrared or I think it's infrared. I could be wrong. Doesn't matter. Anyway, what they do is, so anything that's outside this visible light spectrum, our eyes won't see it. And a lot of this stuff is just coming back as numbers, as a measurement. Okay. Then you have a number that gets correlated to a color. So it's color coded essentially. And what we see is the color coded version. All right, so this is a color-coded version. It may not look like this. And actually, our human eyes, we would just see dark, probably. Maybe some, just because of the type of energy that's being emitted. So the James Webb Telescope is going to be able to look and actually see where stars are born, quote unquote. When a star is born, what happens? Let me go back to this one. When a star is born, they're born in these places called nebula. Okay, so like here's a nebula, and what looks just like dust, we can see through the dust. You see all these stars right here? Okay, so what's happening here is you have a bunch of space dust, which is really, there may be some debris from other planets, but a lot of this is just atoms. One of the things that you'll learn in 8th grade when you get there is, and definitely in chemistry, is that each element or each element has a unique property when it's burned. When it catches on fire, it's going to turn a certain color. That's what makes your different colored fireworks. All right. So we're able to look through this. So what happens is you have all of these atoms that start to accrete or coalesce or congeal or get stuck together. And you have more and more and more of them start to stick together. that eventually what's going to happen is they're going to start to spin because of gravity. We'll get there another time. And as they start to spin and come together, and they're coming together with such force that what can happen is fusion, as in nuclear fusion, as in what powers a star. So you will have all of these things start to come together, and it starts to be this snowball effect. Once fusion starts, it's just going to keep right on going until it burns itself out of fuel, kind of like your car. All right. So there's a little, okay, so let's go back here. So telescopes now. So we've got infrared, and it's going to look, it has a satellite dish. There's no camera. It's just taking measurements. It's collecting energy that's being shot out. The Hubble, this is the picture of the Hubble, or the visible wavelengths. X-ray, it's kind of like a gigantic X-ray machine. Gamma rays, this is some nasty type radiation. There are other telescopes, here we go. And these ones are based on the ground, okay? This one is I believe this one is a radio, yes, a radio telescope. And a radio telescope, you can also see these ones too. These are radio telescopes. They are able to shoot out or to measure long distances. Radio waves can travel very long ways. And so there's this thing, NASA has this deep space network. So that is what Voyager is communicating right now, is on that deep space network. Now it takes a long time for these signals to come back and to go out. So, and also they're like 40 plus years old pieces of equipment. So anyway, so that's that about telescopes. I hope you learned something with that, and have a great day. Thank you.